Yes, good evening, class. I'm going to share the screen to make sure you get the notes, and I'm going to go through this particular class. You're going to have for systems administration. We are going to look at operating systems, and under systems administration, one of the topics we have to take note of is operating systems. So by the end of this class, you'll be able to learn and understand the meaning of operating systems. You'll be able to describe the history of operating systems, explain the features of operating systems. We shall define what a kernel is, its features and its types as well. We shall also look at functions of the operating systems. We shall take a look at the types, merits and demerits, which are the same as advantages and the disadvantages of operating systems. We shall take a look at differences between a firmware and an operating system. Sometimes you may always relate them and think they are the same, and yet they are not the same. We shall take a deep look at 32-bit and 64-bit operating system. What are their differences? Sometimes when you're installing an operating system onto your machine or your computer, you may be confused the exact bit you should be installing. We shall find out their differences between the two. So why I'm recording this class, because of late we have not been having classes of systems administration. I want us to get started with this. So what an operating system is a software. We are aware that it's a software which acts as an interface between the end user and the computer hardware. Remember that when your computer does not have an operating system, you more or less don't do any work. You always have a black screen of death. You always have a black screen. The screen, it's always what? It's always black. Okay, so until you install the operating system, it's the link between the computer hardwares and the end user. The end user, it's you who is trying to use this particular operating system. So you take note that an operating system is a software which acts as an interface between the end user and the computer hardware. So we say that every computer must have at least one operating system. We are using the word at least because you can be able to install more than one operating system on one single computer. For example, your computer can easily run Windows alongside Linux. It can be Linux Mint, it can be Ubuntu, so you can keep always shifting. Your computer can still also run Windows 10 at the same time running Windows 7. So basically, it is you, whenever you are logging into your operating system, you choose appropriate window you want to use. So that's why we are using the one, at least one operating system to run other programs. Now, other programs can be like application programs. For example, we have Google Chrome, we have Microsoft Word, which is one of the Microsoft computer applications. We have games, and there are many games. We have, like, you can play Matatu on your computer. You can play these games, driving games on your computer, FIFA 20, with those who love soccer. You can also play them on your computer, which needs some environment in which it will run and perform its task. And the environment, it always need for you to install these applications, you always need what we refer to as an operating system. So that's why an operating system onto a computer is a core and a fundamental software which is needed for you to install other programs or applications on your computer. So here in this point, we are saying that the operating system helps you to communicate with the computer without knowing how to speak to the computer's language. You want to take a look at the computer doesn't understand this language we keep using, say it English, but the computer understands language in form of binaries, It understands language in base 2. Yeah? The language involves zeros and ones. It's what the computer understands. So it is the operating system's responsibility to convert or divert the text you are trying to, all things you're trying to execute on the interface, to make sure that it understands what exactly you're trying to command, and convert it to ones and zeros, and you're able to go through what you want to do. So it is not possible for the user to use any computer or mobile device without having an operating system. You remember that, of course, when you talk about operating system, we don't only mean that operating system works only on a computer, say it a desktop or a laptop, but it also works in phones. You have ever seen when you're powering up a smartphone, it brings something called Android. Okay, Android is an operating system. It brings something called iOS, is an operating system, and many others. Okay, and many others. So these are all operating systems of various devices. A phone, another operating system of a computer, as we move ahead. Now, this illustration, this diagram shows us based on our system requirements, which helps us, these are hardware system requirements, which helps us install the operating system. For you to install an operating system on the computer, you must have the CPU, which is the central processing unit, and you must have the memory, which is the RAM, and you should have the hard drive, which is the hard disk, the storage device. So basically, the RAM can be at least 1.5 gigahertz, and then the RAM, the CPU can be like 1.5 gigahertz, and then the RAM can be like at least 2 gigabytes, and the hard disk can be at least can have a hard disk of like 32, okay, 32 GB, 32 gigabytes. So it is also necessary for us, once you have all this, you'll be able to install what referred to as an operating system. And this operating system can be either Windows, it can be an Apple OS X, or it can be a Linux. Mention them. So it is this which the end user has. So you install operating system on the computer hardware. Okay, you install it on the computer hardware, and what enables you install this operating system on the computer hardware is the CPU, the memory, and the hard drive. And then after installing on the computer hardware, the end user is able to interface with this operating system and perform his tasks. If I want to type a document, it means the operating system is running and I've installed Microsoft applications, MS applications, for example, Word, Excel, PowerPoint, mention them, which helps me go ahead and perform my tasks. Okay, now we need to look at examples of operating system with the market shares. You know, everything has a market. These operating systems are many, but again, which kind of operating system is selling most? When you check in the percentage wise, Windows is selling most, meaning that most of the people are using Windows and they find it more user-friendly to use compared to other operating systems. And there's also Android. Android is the second, is also the second leading. And then we have iOS operating system, which is 16%. It's the third. We have Mac OS, the fourth. We have others, which is 2%. Others, 2%. So market share, Windows is leading, followed by Android, followed by iOS, and you find out that most of the laptops and computers are Windows type. And Android follows, most of them also are under Android, followed by iOS, Mac OS, and then others. When you check this, here's the list of operating systems with the latest market shares. You see, so the latest market share here is 40.34 for Windows, Android is 37.95, iOS is 15.1.44, Mac is 4.34, and then Linux is 0.95. We have Chrome is around 0.14, Windows Phone around 0.06. So Windows still leading, followed by Android, iOS, Mac, and these are the ones we called others. In our diagram, we have drawn the other side, other slide. The history of operating system, which may necessarily not be set, but you just need to know that an operating system were first developed in the late 1950s to manage tape storages. You remember that there were these cassettes, which you guys know. The cassettes, people used to use tapes for playing music in their homes, in the gatherings, on parties. These are cassettes which used tapes, and those tapes were storing music or maybe films. And then we have the General Motors Research Lab implemented the first operating system in the early 1950s for their IBM 701. IBM is business, mean international business machine. Okay, it's a computer. And then we also have in the mid 1960s, operating system started to use disks, the hard disks, the flash disks, and so on. The floppy disk, by then there was a floppy disk. Okay, floppy disk was also a storage what? Device, floppy disk. Then in the late 1960s, the first version of Unix operating system was developed. That's when the operating system called Unix was developed. And then the first operating system built by Microsoft was DOS, disk operating system. It was built in 1981 by purchasing this 86 DOS software from a Seto company. Yeah. And then the present date popular operating system window first came to existence in 1985 when the graphical user interface was created and paired with MS-DOS. Yeah, it's created by MS-DOS. So that's briefly the history of operating system, which I'm sure there'll be no questions about it, but of course it's always necessary for you to know the history of something. Is that what you are studying? Well, let's look at the features of operating system as one of the competences. Here is the summary or the least commonly found important features of an operating system. Sorry, my numbering was not okay. So one is protected and supervisor mode. This means that you can easily create is out. Yes. So this means that it is protected and supervised mode. In other words, you can encrypt your operating system by creating a password and a username, so that in case of you wanted to access some files, you can be able to log in. It also allows disk access and file system device drivers, network security. You can access files, you can access disks, and also drivers for the network security as well. programs can be executed. Yeah, you can execute programs here using an operating system. Look at memory management, virtual memory multitasking. You can manage your memory virtually, and then you have handling input and output operations. You handle input and output operations. You have manipulation of files system. Be able to manipulate your files within an operating system. Error detection, you can solve out errors, fix network problems, fix issues which are disturbing with your machine using an operating system. Resource allocation, you can be able to allocate resources, for example, partitioning your disks, and say maybe disk D will carry my academic file, disk F will carry entertainment, and so on. And then you have information and resource protection. You can protect your information by encrypting. For example, there is a software called folder lock. You can lock your folders from other intruders who may easily access it without your permission. So that is it. So these are all the features of operating what system. So we have a very beautiful diagram here, which shows us how a user gets into be able to interact with his machine. First, you must have a hardware, meaning you must have a computer. On that computer, you should have the CPU, central processing unit. You should have the RAM. After having the RAM, you should have the hard disk with appropriate space, and then from there you'll install the operating system on that hard drive, or I mean on that hardware, on these hardwares. After installing the operating system on this hardware, of course you can install Windows, you can install Linux, you can install Unix, you can install Ubuntu, and many others. After installing operating system on that hardware, you then install what we call application. Install what we call application. Install application softwares. So application softwares can be Microsoft applications like MS Word, Excel, Chrome, web browsers, and many others. Then these are applications which a user interacts with. The user interacts with these kind of what? Applications. So for example, we look at a kernel. So the kernel is the central component of the computer operating system. It's always central because it's located at the center of the computer's operating system. The only job performed by the kernel is to manage the communication between the software and the hardware. So it is in between the software and the hardware, and it is able to manage the communications amongst the software and the hardware. A kernel is at the nucleus of the computer. It makes the communication between the hardware and software possible. Without the kernel, communication can never be possible. For example, if I put on a flash into my port, okay? If I fix in a flash into the port, it will be able to be detected. It's the kernel's work to make sure that this flash is detected. There's communication between the hardware and the software so that I can access the files in that flash. So while the kernel is an innermost part of the operating system, the shell is the outmost one. So the shell is here, it's outmost. This is the innermost. Okay. So the hardware is here, and then we have the user and as well the terminal here. Look at features of a kernel. One is low-level scheduling of process. It's one of them. We have inter-process communication, process synchronization or synchronization. We have context switching. These are all features of the kernel. What it does, it can low-level scheduling. There's inter-process communication where the communication always occurs internally to the computer. And then we have process synchronization. It synchronizes all and the process taking place within the computer, and then the context switching from hardware to software, software to hardware, and so on and so forth. We have types. Basically, we have only two types of the kernel, and these two types are the most popular ones. One, we have monolithic. Monolithic kernel is a single code or block of the program. It provides all the required services offered by the operating system. It is a simplistic design which creates a distinct communication layer between the hardware and the software. For example, when you check about this, okay, this is an operating system. But of course, between these two, there must be a shell, this shell here, which acts as a layer, okay, which acts as a layer in this part, okay, between the hardware and the software. The next is microkernel, manages all systems resources. In this type of kernel, services are implemented in different address space. The user services are stored in a user address space, and the kernel services are stored in the kernel address space, so it helps reduce the size both the kernel and operation. So this helps in appropriating where the files belong, where do these files belong and where do these other files belong. Take a look at functions of operating system. One, we have memory management, we have processor management, input and output management, secondary storage, we have file management, security, device management, command, interpretation, we have job accounting, communication management, and networking. These are all functions of what it does. It can manage the memory, the RAM memory, the ROM memory, and so on. And then processor management. This processor, this CPU manages the CPU. You know, the CPU is the central processor, it's the brain of the computer. It also manages files. It can be able to tell that this it can be able to tell you that this hard disk is full, this one has space, and so on. Device management. You are able to manage the devices into your computer. For instance, if I plug into a flash, I'll be able to see whether it's detected or it's not detected, and even the drivers. You can uninstall or install the drivers of a particular device. Or for example, a printer. You can install a printer onto your machine. Input stock output management, you are able to know when you're entering data and also displaying data to the required people. Maybe using a projector. And so secondary storage management, you're able to store data into your machine. Security helps you provide for security by providing password. You are able to decrypt and encrypt your data as well. Decrypting means remove of password, and then encrypting means you're trying to create password to protect your data from an intruder. Command interpretation, you're commanding using a command line interface. It is able to interpret that. Networking, you're able to network using your computer. Perhaps if you have Ethernet cable, they're able to be detected. I have software, network software, they're able to be detected, and so on. Job accounting, need to be this job very well. Can account your job, how much have you done at the end of the day, you know, those kind of things. It's able to do them. So all these points have been explained here very well. You can read them through and be able to understand. They're self-explanatory. You might have even met the functions of operating system before. Let's look at types. For types of operating system, we have the batch operating system, we have the multitasking or time sharing, we have the multiprocessing operating system, we have the real-time operating system, distributed operating system, network operating system, and then mobile operating system. For the batch, some computer processes are very lengthy and time-consuming. Yeah. To speed the same process, a job with a similar type needs are bunched together and run as a group. So you even know that when you do work as a group, it takes a shorter period than when an individual does it. So it's the same approach with the bunch operating system, that it groups things, makes things to a group and does it as a bunch or in a group to get done very well. So multitasking is a time sharing operating system, enables people located at the different terminals to use a single computer system at the same time. Yeah. For example, if you check on the bank has a central database that all the branches are able to work within that bank. That means anyone can get into the database and create an account for a client, give feedback to the client, because they have a centralized database. So that's the same with the time sharing operating systems. Now, at the end of the day, they can do these things at the same time. A real-time operating system time interval to process and respond to input is very small. For example, military software systems, you remember in military, you're going for the war, you don't need something which will take a little bit longer time. Yes? I'm having a class. Give me some time. So you don't need something which will take a lot of time in the military. You need a software which does work so quick, and that's a real-time operating system. It has to respond in a very, very short period of time. It has to be distributed operating system. Distributed systems use many processors located in different machines to provide very fast computation to its users as well. So in this place, many processors are being used in different locations. When we talk about processor, we are meaning CPUs. Network operating system runs on the server. Some of these network operating systems can be like pfSense, which runs on the server. It is used for monitoring, to keep a close eye on the users. It also provides capability to manage data, users, groups, and security as well. Mobile operating system. These are those operating systems which is especially that are designed to power smartphones, tablets, and wireless devices. Some most famous operating systems are Android, we mentioned them, iOS, even you have them on your phones, but others include BlackBerry, Web, so on and so forth. Then watch operating system. Differences between firmware and operating system. A firmware is one kind of programming that is embedded on a chip in the device which controls the specific device, whereas operating system provides functionality over and over that when is provided by the firmware. So you can see that this operating system, for it to do its job, it should be provided by the firmware, and this firmware it's always embedded. It's just an embedded chip into a device, which gives control for the operating system. So second is a firmware is a program that be encoded by the manufacturer of an ICE, integrated circuit or something, and cannot be changed. It cannot be changed. And then OS is a program that can be installed by the user and can be changed. So the firmware, basically, you can't change a firmware because it's made by the manufacturer himself, and it's by the ICE. It's in the ICE format. And with the operating system, you can change it. I can install Windows 10 and change it to 7. I can install Linux and remove and put Windows. So firmware is not something you cannot change, but operating is something you can easily change. It is stored on a non-volatile memory, whereas this one is stored on the hard drive. So this is stored on non-volatile memory, but this one is stored on the hard drive, meaning that when you switch off the computer and power it on, your operating system will load because it's stored on what? On a hard drive. But when you look at about a non-volatile memory, you are taking a look at something called ROM. Okay, so meaning that it can be stored also permanently on the ROM as well. It's not there. Okay, let's move to the next. The difference between 32 bits and 64-bit operating system. Most of you must have been trying to install Windows on your computers, or you have never tried, you're yet to try. I should take note of this, that 32 bits and 64 bits have differences in the form of architecture and softwares. It always allows 32 bits of data processing simultaneously, and this one allows 64 bits of data processing simultaneously. Compatibility: 32-bit applications require 32 bits operating systems and CPUs. 64-bit applications require 64-bit operating and CPUs. So they are always different. System availability: all versions of Windows 8, take note, Windows 7, Windows Visitor, XP, and Linux, etc. They can be run with 32 bits, and then all Windows of XP, Professional, Visitor, Mac can also run with 64. 32-bit systems are limited to 3.2 GB of RAM, okay? But whereas 64-bit system allows maximum of up to 17 billion GB of RAM. You can see this is a limited thing. 32 bits is limited. When you're installing Windows, it always asks which bits do you want. I would advise you should be choosing 64 bits of Windows or operating systems, because it's better off and can allow you install as any program as you want. It's not limited. It is open. You can run any software. You can run a software which has which have 32 bits on 64 bits. I cannot run a software which has 64 bits on 32. The reverse is not true. And so here comes the advantages of operating system. One, it allows you to hide details of hardware by creating an abstraction. You can hide details of the hardware. Easy to use. Why? Because of graphical user interface. It's user friendly. Offers an environment in which a user may execute programs and application, which is true. For example, if you have Word, you have an environment that can execute the close, open, delete, do many things. Operating system must make sure that the computer system is convenient to use. Yeah, it always does that by giving you a graphical user interface. Operating acts as an intermediary among applications and hardware components. Of course, it's always in the middle, making sure that those two communicates. What I'm trying to write is hardware and software applications communicating. It provides the computer system resources with easy to use format. It is always very easy to use and acts as an intermediate between the hardware and the software. Definitely, it's always in the middle to coordinate programs of software so that they are compatible to the hardware and there to be communication between the two. Disadvantages: if any issue occurs in operating system, you may lose all the content which have been stored on the system, which is true. You can easily lose data. Operating system softwares is quite expensive for small organizations, which adds a burden to them. For example, Windows, true. Windows is very expensive. Windows is very, very expensive. You have to buy a licensed Windows. It's very expensive. It is never entirely secure, as a threat can occur at any time, especially Windows. It's always very easy to to use the dictionary attacks to hack into your Windows, and even writing passwords on the walls. So is there I can uninstall Windows on your machine by installing another one, and I'll get it to your machine. So it's not entirely safe. So in summary, we say that operating system is a software which acts as an interface between the user and the computer hardware. Yeah, and operating systems were first developed in 1950s to manage tape storage. Then we also say the kernel is a central component of the computer operating system. Central meaning it's at the center of the computer operating system, and its job is to perform. The only job performed by kernel is to manage communication. Take note, it's to manage communication between the software and the hardware. And then the two most popular kernels are monolithic and micro kernels. These are the two types. Then the processes, device files, input, secondary storage, memory management are various functions of operating system. Then we have the bunch, multitasking or time shading, multi-processing, real-time, distributed, network, mobile. These are the types of operating system. The question can easily come. Explain the types of operating systems you know. So you should be able to answer that. So we have come to the end of this class. But make sure you take key points in this particular class. So I wish you well. We hope to meet again. Bye-bye.